Geometric mean, another type of mean and another way of measuring central tendency. The whole calculation might seem complicated, but at the end of this video, you will get this clear in your head. I am requesting all my viewers to take your notebook and write it down just the way I am explaining so that you can't get confused in any step. So let's get started. We have taken an observation for the variable x. Okay, that's why we have written x1, x2, xn. Now, geometric mean of these set of observation is nothing but the nth root of their product. Their product, this is the product, x1 dot x2 dot xn. Okay, and we have taken the nth root. Just the way we take square root, we have taken here nth root. Why nth root? Because we have n number of observation. We usually take the total number of observation as the reciprocal of their power, okay, which is called the nth root of their product. As you can see, this we can write it like this. As you haven't seen my 10 fundas video, then you can click on the I button right now, and I am explaining a bit. These are the products of n observation. We can write it like this. This is the way of showing the product of n observation. Okay, it's just the way of showing. Don't get confused. There is nothing to understand here. Now we have taken log. Why we have taken log? Because whenever we have complicated algebraic equation, in order to make our calculation easy, we take log. Okay, so we have taken logarithm on both the sides, as you can see, and this is the formula for logarithm. Wherever we have a power and whenever we take log, this power comes down here. Okay, so we have broken down this thing. This is nothing to be worry about, because these are all the formulas for log, and if you are not clear with this logarithm formula, then you should clear this by now. And if you want me to explain, then I am going to explain it sooner. So these are the products. Whenever we take log, what do we have to do? Log of any product becomes the sum. Okay, so that's what I have written. After taking log and after summing down here, we can write the summation sign. And this also I have explained in the 10 fundas. If you haven't seen it, just click on the I button again. Okay, so these are the summation. We have denoted this by sigma, where I is running from 1 to n. Why I is running from 1 to n? Because we have taken the observation from 1 to n. And when you have to calculate g, which is the geometric mean, you have to take log on both sides, which is nothing but the exponential to the power this equation. Log of gm is nothing but the am of the log of observation. Okay, log of gm is nothing but the am of the log of observation. These are the observations. We have taken log of the observation, and this is nothing but the am of the log of observation. I hope you got this clear. Now, as you can see, whenever we have frequency distribution, because obviously this is not possible that we won't get a data without frequency distribution. And whenever we take frequency distribution, we kind of actually simplify the calculation. But here, as you can see, this might seem very clumsy, very complicated, but this is most easier method to calculate geometric mean. Okay, so just stick to this video. If the observations, we have taken the observations earlier. Now what we have done, we have taken their respective frequencies. Okay, we have frequency for x1 as f1, x2 as f2, and so on. Okay, for geometric mean, or for calculating geometric mean, you have to take the product of the observation with their respective frequencies in their power. With nth root is the total frequency. Nth root is nothing but the total frequency. Okay, here capital N is nothing, the summation of Fi. Fi is what? Frequency. Now we have taken logarithm on both the side. As I have explained earlier, whenever we have a complicated algebraic equation, we take log. And this is the formula for log. Whenever we have something in the power, we take it out here, and after multiplying it, we have this formula. Again, what we have done, fi is in the power section, we have taken out here, and this all product becomes summation. Okay, we have done nothing in the another step. We have just denoted this whole series with the sigma attached to it, where I is running from 1 to n, where log of g is nothing but the am of the log of what? Log of the observation, which is again our earlier proof. So there doesn't create much difference. There is just minor formula change or change in the formula. You don't have to get nervous. And whenever we have continuous or group frequency distribution, we have to take x as the midpoint of the class interval. Okay, I just hope you love this video. Thank you so much for watching. If you have any doubt, comment down below. Okay, bye bye. I'm signing off now.